Now we're to number 7. To find the number of moles of CO2 that exert a pressure of 785 mmHg, or milliliters of mercury, at a volume of 32.5 liters at a temperature of 30 degrees Celsius. Okay? First things first, let's assign these variables. Our equation is PV equals nRT. So we have to write out our PV nRT on the side. Okay? Now we want to find the number of moles. So we don't know what our N is. And then we want to find that exerted pressure. Our pressure is 785 milliliters of mercury. Our volume is 32.5 liters. Our R is in we need to find the R with millimeters of mercury. Just right here. There we go. 62, 0.4. Okay, and last but not least, we have our temperature, which is 32 degrees Celsius. All right. All right, 32 degrees Celsius. Our next step, we have to make sure we add our 273 because we want to make sure our temperature is always in kelvins. 32 equals 305, I believe. No. Yes. Maybe. 305. Yes, it does. Here we go. 32 plus 273. That's wrong. Okay. Plus 273. There we go. 305. The old trap's still working. Alright, I'm going to straighten this a little bit for y'all just so it looks a little better. Next thing, we're going to plug in all our variables. Okay, 775 or 785 times 32.5 equals N times 62.4 times 305. We want to get N by itself, so we're going to divide the right side by the left side. But first, I always multiply my my numbers together. So we have 785 times 32.5. And that gives us 25,512.5 equals, now we're going to multiply the right side, 62.4 times 305. Gives us 19,032. Alright, so let's do 25. We want to get, if we see that we still have N over here, we want to get N alone by itself. So we are going to divide both sides by 19,032. Okay. All right, and our final answer is 1.3. It's 1.3. We rounded to the second significant figure, as with the temperature. And the units of this is moles. All right, so we have 1.3 moles. We're on number 8, our last problem for this worksheet. What is the pressure exerted, what is the pressure in ATMs exerted by 0.5 moles by a 0.5 mole sample of oxygen gas in a 10 milliliter container at 298 kelvins? Oh, they're nice. They gave us in kelvins this time. Okay, so we're looking for pressure. P question mark V, and first thing we assign our variables. So that's what I'm doing. Here we go. PV equals nRT. What pressure is exerted by, first thing they give us is moles. Second thing they give us is a 10-liter container. 10-liter container at 278, and we want the pressure in ATMs, which gives us our R, which is our ideal gas constant, 0.0821. Next thing here's our equation, our ideal gas law equation. We're going to plug everything we know in. We don't know what P is, but we do know what V is. We know what N is, 0.05. We know, sorry, that's an ugly 5. We know what R is. And we know what T is. Let's go in. What do I always do first? Multiply the sides. I'm going to multiply the right side first. Well, this side is 12.2329. 12.2329. We want to make sure we get this 10 by, we want to make sure we get the P by itself, so both sides get divided by 10.0 divided by 10. Our answer is 1.22329, but we have to round it to the correct number of sig figs. Correct number of sig figs in this problem is just 1, so it's going to be 1. 1 ATM. There we go. We've done it. We've managed to finish all of our problems. Good job, everybody. Thanks for watching. Thanks for watching. I'll see y'all next time.